Oh, finally we're back. What were we talking about?
I'm really good at this, remembering exactly what I was saying 2 seconds ago. Even better if it means having to remember what we were talking about a week ago. And I reckon we just get straight back into it.
Go.
I've got one there, Tim, because the interesting thing is we had recently a seminar, and I didn't get the wow factor on the actual, like, if you can see the picture behind me. The reason I put that up is because you have a photo with the aggregates, you see a lot of good color, good reflection there. But then there was a slab, and I was talking to Josh about it, and I was saying it's not doing it for me. It's not the results where I'd like it to be. And I was just trying to understand to where this came undone. And not that the result was bad, but it just didn't have that pop. It almost looked like a marble, really. Josh, do you want to elaborate on that a little bit? Because you were there, you can sort of explain it probably a little better than I can.
Oh, no, Daniel, I was wrapped with the results. We just didn't have alignment on our expectations. Yeah, so like Daniel said, when we got to that 400 grit stage, like Daniel said, it really was lacking that crispness to it. And also as we got higher up, I have my understanding as to why we don't see the same level of crispness and at the stages where we expect to see them. But yeah, it's certainly was a very appealing, nice looking slab, as you can see from behind Daniel. But it didn't have that same level of sharpness to it that we see, particularly when working with slabs that have got more natural sands and harder aggregates in them.
I mean, it could be a lot of different things, Daniel. I mean, we were just talking about aggregate there, but my understanding that was a fairly new slab from. That's correct. It wasn't that old. 2 weeks.
Yeah, 2 weeks and about 75 mil depth, 75 to 80 mil depth. So we still haven't reached a full cure on that.
Look, there's so many different factors that could be influencing that. I mean, I've sort of made a couple of notes before this talk. I mean, things like, this is probably not necessarily the case in your particular one, but moisture levels in concrete. Okay. The higher the moisture levels that are going to be in concrete, and these are all things that are actually measurable. Not many people do them, but moisture levels are going to increase the ability of our chemicals to actually react and do their full cure when it comes to sort of our densifiers and our grout, for argument's sake. Okay, aggregate hardness we've talked about, additives, particularly with accelerators and all these different materials that are putting into concrete, whether they are there to accelerate them, whether they're there to make them more flexible. So all the different polymers and plasticizers that are being put in concretes. And we know this from overlayments. I mean, overlayments is another really sort of similar topic where it's often very hard to get really crisp, polished results on an overlayment, depending on the material and manufacturer and how old it is, of course. But often with all these plasticizers and polymers, because we're using a dry polishing process, they don't like temperature. And we actually do generate quite a bit of temperature with our tools. So if you've got these sort of plastics that are holding particles and pieces together, and as something is rubbing over top of them, they're getting warm and they're starting to get a bit soft, and they therefore don't hold on to these little fine particles so well anymore. They can get pulled out, and those fine particles actually leave little voids, which again affect our reflectivity of the material. But they can also create their own scratches in the process too.
Yeah, and so that plastic polymer, we also it's no longer a dead flat crisp line anymore, is it? It's been exposed to a lot of heat, and that then changes the shape, I guess, of the particle itself, and therefore we also lose that direct line of reflectivity.
Going back to what you're saying about a newer type material and something and moisture and that sort of thing, is that something that I suppose can go hand in hand? But quite often I've heard from people that they go back to a job that they've done 6 months later, and the floor's almost sort of caught up to itself. It's still reacting to the chemicals and that were put into the floor, and it gets tighter and tighter and almost looks better 6 months later than when you originally did the job. and you had a great result. But it's funny, they go back and say, geez, it's even better than what I remember finishing up with. So just the moisture levels catching up, also the reaction of the chemicals that were put into the floor as well. Is that something that can sort of catch up with itself a little bit?
Well, definitely concrete is continuing to change over time, Mike, because the reality is not every particle of cement that's in a batch of concretes actually comes into contact with water properly, or is properly what we call hydrated, okay? So if you have dormant cement sitting in a concrete slab, then if you have moisture moving through that slab over time, the argument can be made that those dormant pieces of cement do become hydrated over time, right? We also know that it's through that wetting or that hydration, that reaction of cement with water, that we get the calcium hydroxide, which is that byproduct that our densifier reacts with. So certainly time, curing and proper hydration of concrete, or cement I should say, are all different factors that affect the outcome of the floor. And of course, if we've got plasticizers and sort of things like that are, let's say, lining pieces of cement and so forth, so they're actually creating a bit of a barrier for the water to come in contact with the cement, that's going to affect the reaction and this calcium hydroxide that's available for our densifiers to react with as well. So there's lots of things going on, lots of different variables, and they happen over time. It's not a static process. You know, all the testing for concrete's done at 28 days. Okay, it's not because the reactions are finished or anything, but it's just the standard point where over time that we know a lot of that's actually happened, and that's a good time to actually get measurements and have a consistent reference point.
Bit of a baseline.
Yep.
The other thing I take from that, guys, we talk about this. Think about what we have control over in a polishing process. That is the tools that we use on a day in, day out basis. And the one thing that we don't have control over and that affects our process dramatically are the materials that are changing constantly. So I guess if we can take one thing in control, that is consistency, using the tool that you know that's going to work day in, day out. So that's why I think, if you can also keep these particular tools in your toolbox at all times, you always know how they're going to work, because not always a different tool is going to fix the problem, because the problem could lie not in your tools, the actual process and the materials.
And like you say, Dan, if the materials are ever so changing, it becomes even more important, as I mentioned before, when the materials are provided to you, to do that sample and really then set the expectation. So there's no question marks when you get to that 400 stage thinking, oh, this is it, I'm going to finish, this is it. And then you look back and you're like, oh, wow, this needs more work. And then you're going to be disappointed. The customer might be disappointed, but end of the day, it's more likely that the contractor will be disappointed because they're spending more time on the site because they didn't foresee this. So run those samples if you're not sure.
That's it.
Yeah, and get batch reports so you know what type of materials that you're working with before you go in there. That way you can educate your client.
Josh living in his perfect world.
Let's face it, we'd all rather, well, not rather, it's a much better position to be coming from if you can blame the concrete from the beginning rather than at the end. It doesn't have a lot of credibility when you're standing around at a finish. You've gone through the whole process and you sort of turn around to the client and go, yeah, the concrete just wasn't very good on this one. I mean, it doesn't make you look very good.
Yeah.
So I'm with you, Milan, absolutely. Let's work out what we're working with from the very beginning. And like Daniel mentioned, what are our options? What are our tools in the toolbox to get the best result out of the piece of material we're working with?
Yeah.
And let's understand some of those components so we really know how to manipulate for our advantage.
Well, the one key takeaway I took away from this, thank you, Tim, having let's say a softer slab, softer materials, and your 400s cutting more aggressively than they would generally on a more slab that has got more integrity. So that's actually a really good one that I picked up. Thank you.
You're welcome.
Awesome topic, guys. Tim, thanks very much for joining us and explaining the different types of materials that are in the concrete. And guys out there, remember, do a sample if you're not sure. It's going to save you a lot of time, and it might save you a lot of awkward conversations at the end of the job when things don't go as planned. So until next week, guys, I think it's time to crack a beer and head on into the weekend.
So
and organise the batch reports for next week.
I think there's lots of moisture inside that glass that needs attending to.
Well, thanks, guys. Thanks for having me, and I'll see you in a year.
Thank you,
2023.
There you go.
Great weekend.